Okay, uh, I'll share my screen. I hope my screen is visible. Just a blank page. You can unmute yourself and speak up if you want. Okay, so what we have covered in the previous two sessions is ANN and CNN. So ANN stands for artificial neural network. That's the very base. And then we have CNN, that is convolutional neural network. It is for the images. And today we are going to cover RNN. RNN stands for recurrent neural network. And along with that, we will also cover LSTM. Okay, so these are very crucial when you are getting your journey started with GenAI, because GenAI is based on all of this. If you don't understand these based, understanding GenAI is not easy. It's not just writing a prompt and running the query. You need to understand what goes behind GenAI so that you can provide the solution. So, what is RNN, or recurrent neural network? What do we mean by recurrent? Anyone wants to take a hit on that? What is recurrent? I hope I'm audible. Yes, exactly. Something that repeats. Now, anything, if I am repeating within neural network, that will fall under recurrent neural network category. So, whatever you are feeding as the input, output is generated, then again it goes back as an input. So, it is recurring itself. For example, if I give you a simple analogy in terms of Indian TV series, suppose all Indian series, web series that you are having, or any web series, what happens if you directly, you haven't seen that series, suppose, and you directly jump to the fifth episode. That series is of 10 episodes, and you directly jump to the fifth episode or the second season, something like that. You won't understand the context, what's happening, why this person is sick, or why this person is laughing, or whatever is happening. You won't understand that until and unless you have any prior memory or the prior linkage to the previous episodes. So what is that? You need to understand the past. If you don't know the past, you won't be able to understand the present, and you won't be able to predict the future. That is the story of recurrent neural network. So far so good, guys. Okay, so now the question would be why. I'll explain what is recurrent neural network, but before that, why we need to learn so many different neural networks. So, why you need to learn so many different models in together altogether? It is because there are so many different types of data, different types of problem, different complexities that you have, and different features that each and every model has its own, as well as what it can handle. So that's the reason. What is ANN good for? It is good for your simple tabular data. Okay, it works very well with your simple tabular data, whether it is classification, whether it is your regression. It works very well with the fixed size input and output data. It doesn't remember anything in the past. Okay, so it doesn't remember anything. It treats everything, every input that you are giving as independent. So it is like any other classification or regression model. It's just that it is more complicated. It processes, it learns from its own mistakes. It works on the gradient descent thing. That's why it is better compared to other models. And but it is still a black box model. Now coming to CNN. What is CNN for? CNN is convolutional neural network. It is for your images or your spatial data. Okay, which spatial data means that is your pattern recognition in space. So it understands that pattern. It is not into the time relationship. time relationship is not happened, that what happened in the past or something like this. This is not possible in CNN. But in RNN, we require this thing. We require the time handling, what happened in the past, how much it is going in the past, like one day, one week, or how much context is there that it is going in the past. So it works on sequential and time based or time based data, like your uh, audio, your stock prices, your text, all these things it will work on. It is designed to handle the context in time. Are we good, guys? Any doubts, any questions? Okay, great. So now let's move on to understand what is a recurrent neural network, or how it is used. First of all, where all you can think it is used. What is the usage of RNN? Anyone wants to give it a shot? Yes. Sorry? Right. Yeah, chatbot kind of a thing. So that will come under your NLP, natural language processing, where you can have text generation. Like when you write email, that auto completion happens. Even your WhatsApp message, that auto completion or text correction, all those things happen. What is that? That is backend is RNN. Okay, your language translation from Hindi to English, or from any other language, from English to Italian, German, French, whatever you have. So the what is that? That is also your RNN. It understands what is the first word, it is building up that context, and then it is giving you a meaningful output or similar output in a different language. It is not something random. Then for speech recognition, like your Alexa, Google Assistant, all these are working on your RNN. Your chatbots, as you mentioned, your customer support, your banking, telecom chatbots, or anything that you have conversational flow, that is also through RNN. Your sentiment analysis, that if I'm giving the movie rating or something, or I have this Amazon reviews and all, what is the sentiment behind that? Right, if I want to analyze it is positive or it is negative. Why? Because the meaning of each word depends on the previous word, that what is the context of that. Okay, then it is used for your speech and audio processing, speech to text conversion, your music generation, speaker identification, emotion detection in the voice, for time series forecasting like stock price prediction, weather forecasting, bank transaction analysis, your sales forecasting, your sequential data and IoT and sensors, that is your vehicle telemetry, your smartwatch data, video and motion analysis for your healthcare applications like patient monitoring, analysis of heartbeat, BP, ECG, tracking the diabetes or the heart condition of a patient. All these things are through RNN. They are possible to RNN. RNNs now are replaced by transformers that we will cover in LSTM, but RNNs are the foundation. They are still the foundation for understanding how machine learns sequences, just like you learned your first alphabet before you write any letter or any essay or any question answer. We learned our alphabets, right? Similarly, RNNs are the foundation, and that's why it is very, very important to understand, because your Gen AI is also based on transformers. Okay, anybody knows what is the full form of GPT? Anyone? Chat GPT, everybody uses. What is GPT? It is generative pre-trained transformer. That transformer is the essence of all this Chat GPT, Claude, or in any model that you have in Gen AI. And your transformers are uh, brought to life because of RNN. If RNN wouldn't have been there, transformers won't work. So the foundation remains same. Any doubts, guys, till now? Yes, no? Are we good? Okay. So let's understand what is RNN or how it behaves. So, how many of you know about the hidden layer in neural network? Yes, no, guys. Do you know what is a hidden layer in neural network? I've covered in my previous sessions. But anyhow, if you are not aware, I'll quickly brush it up. So I want response if you are aware or you're not aware. Okay, okay. Fair enough. Still, I'll just quickly cover this thing. You have three layers in any neural network. One is your input layer, then comes your hidden layer, which has your neurons. Okay, hidden layer, and final is the output layer. You can have you will have one input layer, you will have one output layer, but you can have multiple hidden layers. Okay, it applies. So whatever input you will give, it will go to this, then it will go to all the neurons. Second input, it will also go to all the neurons like this, and this will be communicated to output, and finally you will get one output. It assigns your weights, activation functions, and all these things. So hidden layer, you can understand that hidden layer is like the hidden chef in the restaurant who doesn't come out to serve you or tells you who's a person behind this dish until unless that dish is very good. So you tell, okay, these are the ingredients, I want this kind of a dish and all those things. That chef will make that and give you the final dish as the output. That's what is the rule, or the role of the hidden layer. Okay, you have it in ANN, in CNN, in RNN, in your trans, everywhere you have hidden layer. Hidden layer could be multiple, so it behaves like a brain. We don't know what is happening inside our brain, right? We just have the input, we see something, and we give the output, we react or we say something. So that's what is happening inside the brain, how it is processing. You don't know this thing, and that's why it is known as hidden layer, and it has neurons inside it. Okay, any questions, guys? Okay, so now let's move to RNN. What is RNN? Your, as I told you, RNN stands for recurrent neural network. It is a type of a neural network that can remember past information to understand the present. So if I say how are dash, right, what will happen? Your phone, your email will suggest, what will suggest the word that is you over here, right? How are you? It will suggest this thing because it has some past context. RNN are used for sequenced data, as I told you. So this is the diagram for RNN. You can have a horizontal diagram also. I'm making a very simple, easy to understand diagram. This is your hidden layer. As of now, I'm just making one hidden layer. You give one input. Let's say that input is X. Okay. And you get one output, which is Y bar. Again, if you give an other input, so this input was given at xt time t. Now you give another input which is at xt plus 1, right, an additional time. What will happen? Whatever is this output, again it would be served as the input to this, along with that new word that you are giving in the new time frame that you are giving. So what is this? This is the past information that is going to your recurrent neural network. So it is recurring again and again, and like this it will happen for each and every word that you have. So when I am giving how, it is just one word that is getting into RNN. It would be stored, it will get generate some output. Then in the next context, what will happen when I'm giving R, whatever is the output of how, that will also go into R. And based on this past information, it is going to give you the current output that you are having, or it will give you the current suggestion that is you. Is this clear, guys? Yes, no? So the only difference that you have is that what compared to other neural networks is whatever is the output that you are having currently, it will be fed for the next word itself. Okay, so if I show you this, see this. Input RNN, output I am getting. Input 2 RNN, output 2. Same RNN is there, input 3 and all this thing. Output 3 is going to output 2, output 3 is going to output 1 also, output 1. So like that, whatever is the sequential, it will keep on getting. Output 1 is going to output 2 also, output 3 also, like that. It will keep on iterating itself. That's why it is called as recurrent neural network. Output of one will go to input of two, in output of two will go as input to three along with the new input also. Okay, if if I give you a simple analogy again for this thing, if I say today in breakfast, or yesterday I had dosa in breakfast, today I'm having idli, tomorrow will I like to have idli or something? Yeah, if you're too fond of, you can have it again and again, but again you will think, okay, let's change it. We had dosa idli, now let's make poha or something like this. What's there? It's your past memory that is happening, and that's what is recurrent neural network is also doing. Clear, guys? Any doubts, any confusion? Okay, there are many types of RNN. What are the different types of RNN? One is which we call it as vanilla neural network. It is one to one. In that, you just give one input and you just get one output. Like there is no sequential or the past history that you have. If I'm saying, if I'm saying predict if it will rain today based on today's humidity and temperature. So it is just independent day that I am having. It is not about the past, what was the weather and all those things. So this is a simple classification or a regression task, which is also possible to RNN. So this is one to one. Then you have something as one to many. One to many is what it means, is that you have one input and you can have many output. Like if I am giving a simple note, simple this music note, or the word to my model, it will generate some output. Like if I'm asking Bollywood love song, it might give me dil se tere naam tum mile or something something. It will give you, right? So one input, but you can have many output to that. Generally the examples, or generally where it is used, is music generation, text generation, and even your image captioning that is there. That is also something, an example of your one to many. Then the third one is many to one, means you have many inputs, many sequence, and you just get one output. You give the complete multiple reviews of a movie and you say what is the sentiment, people are liking it or not. Or you are giving 10 days Sensex data, you are saying predict me next day data or the 2 days data, like that. What you are giving, you are specifically asking for one type of output, one output, but you are giving multiple inputs to that. You are just asking predict the stock price, whether it will go up or down tomorrow. So what is that? It is many input but one output. So it is sentiment analysis, your time series prediction, stocks, or your weather forecasting. All these things are your many to one example. And then you have many to many. What is many to many? It has two subtypes. One is of equal length sequence. Like if I am saying something to the translator, Google Translator, aaj mausam acha hai, it is giving me the output, the weather is good today. So what it is doing, it is converting whatever is in Hindi to English. You gave equal, whatever is the size of the first one, it is giving you the output as the next one of the same size. Then there is different length sequence in many to many. What you have, uh, it this auto typing, okay, your auto text generation or auto complete or your text generation or chatbots, these are many to many example. Like I'm saying good morning, it can predict good morning mummy, good morning xyz, good morning sir, good morning. It could be anything, multiple combinations are possible over there, right? Input, or it could be good morning, good morning, how are you feeling today. It could be anything in that. So you have different length, you have one input you gave and it could generate you multiple length output, but again it is many to many. So these are the different types of RNN. Are we good, guys? Any questions? This is the basic of RNN which you need to understand what happens. We are not going behind the maths of this, that how the activation functions and all those things are working. That is not required, because we are here for Gen AI. This is just to understand how to get to the Gen AI, what is the journey. That's why I'm covering ANN, CNN, RNN and all these things. Otherwise, if somebody would have known this thing, this is not required at all. You can directly jump to Gen AI, but understanding what are transformers and all these things are required. Now, why do I told you we will cover one more topic, that is LSTM, because it is nothing but your type of RNN only. So, what is LSTM? Anybody knows what is the full form of LSTM? Okay, how many of you have watched Gajni movie, or at least know about Gajni movie? Anyone? None of you have watched. Guys, at least be responsive. Something, yes, no. If it is dual way, it is good to conduct these sessions. Otherwise, it becomes too monotonous for me also. Okay, no worries. So, as I told you, Gajni movie. So, what was the problem in Gajni movie? He was having short-term memory loss, right? Very for a very small duration, it will remember what happened in the past, and that was the problem. Same problem occurs with RNN. They can remember only and only short-term patterns, but they will forget the long term information because they have a problem known as vanishing gradient problem. Okay, it is vanishing gradient problem. So they have short term patterns. That's why we require a advancement on top of that. And like if I'm saying a long sentence, something like this, a boy who lived in Delhi and studied at IIT became a famous scientist. The Let's say it was just the boy who lived in Delhi and studied in IIT became a famous dash. Your system has to predict. The word predicted should be scientist. So what is there? This is a long sentence. Your RNN might not remember. Most of the times it doesn't remember, but your LSTM will remember, and that's where it comes into picture. So what is LSTM? It stands for long short term memory. Long short term memory, still short term, but longer context, longer duration. Okay, they have a special cell additional to your hidden layer and all this thing. It is a special kind of a RNN which has a memory cell to store a little longer context. It stores the important information for a longer time period, and that's where LSTM is type of RNN only, but an advanced version of your RNN. It can if I give you a simple example, your RNN might be able to remember only 2 to 3 words, or just few seconds, whereas your LSTM can remember the whole sentence or the whole sequence. So that is easier to predict. The output that you generate is same, is meaningful, it is in context that you have. uh, Normal RNN is like a commentary with short memory. Means just remember the last over of the cricket, whereas LSTM will give you more accurate details starting from the first over till the last over, all those things. So LSTM is needed because it helps RNNs remember important information for a long time and forget any irrelevant details. Is this clear, guys? Yes, no, anything? Okay, thank you. So that's what is LSTM. So what LSTM just does is it is an improved RNN. It can decide what to remember, what to forget, and what to output at each step. So there are three gates in LSTM. Again, I will not go into much detail of all these things. Uh, uh, these are the pointers that you should be aware of. If somebody asks, so which one is forget gate, then you have input gate, you have cell state, sorry, and then you have output gate. Now what are all these things? What is forget gate? It decides what information to throw away, means what is useless info, it will discard it. For example, if I give you a sentence, write a sentence over here. Um, X, or let's say Raj likes to eat dosa every day. His favorite cuisine is dash. Okay, this is what I want my system to predict. So what will this forget gate do? It will reject all the useless information, and the one that you can see highlighted in green, it will store it. Why? Because his favorite cuisine is Indian, or you can say South Indian, whatever. But that is based on dosa. That is the input. What is the important information that I have to keep? That's what your system is remembering. Now, how all this will occur, that I will get into later on. Input gate, it decides what new information to add. If I say Raj likes to eat dosa and chola bhatura. So after dosa, chola bhatura is also coming. That is also something that it will store. But if I say Raj likes to eat dosa and that is and it is waste for me. It is useless information. So what is this input gate? It will learn new info. What is the important new info? It will learn that. What is the cell state? Cell state is your nothing but the memory itself. It is the memory, the long term memory is known as the cell state. Output is what output, what to speak now, or what is the prediction that I have to give. That's what is the output that this output gate will generate. These are the four things within LSTM that you need to understand. Three are the gates: forget gate, input gate, and output gate, and one is the memory cell, that is the cell state. And how it remembers all this thing? Any idea how will your system know what to reject, what to keep, how it will remember? Any guesses? It is based on your simple machine learning. How your brain decides? How do you think? So it is based on its past training, it is based on its past memory. It decides what part of the old information to throw away, what part to keep. All these gates and all will help. So LSTM smartly remembers only the important steps and forget all these things because it is trained like this. The model is already trained on the data, on this past training that has happened. Based on that only it will remember. Same thing, when some useless person is talking to you, you will not pay attention because you know from your past history that this person will always talk useless. Okay, you might be listening, but you will just keep on doing your work. Or you will just filter that out. If he or she is giving you some important information, fine. Same way happens with LSTM also. So what happens is, step by step, if I say, if I give you a simple analogy of a student preparing for exam. So if I go with forget gate, as a student you decide to ignore old or unneeded notes. Okay, you will just focus on your current semester syllabus. In LSTM also, it multiplies the old memory by the values 0 and 1. To forget part, it will 0 it means completely forget, 1 means completely remember. Like that, it gives the binary outcome, and based on that it will keep the memory over there, keep that important info over there in the memory. Then next comes as the input gate. When you are preparing for your exam, what you will do? You will store the new information as per the new subject or what you are learning today. LSTM will also decide which part of the new input, the X that you are giving, to add to the memory, whether it is important or not. Then in your notebook, what you will do, you will write the useful concept. Okay, this, or you will mark this is a very important concept, or this is an important question that might come in the exam. So that is what LSTM also does. It is updating slowly over time, and it keeps so that your information doesn't get erased. It just keeps storing it in the self state or the memory. And finally, output, when you are going to the exam, you will be able to recall that input and the memory thing that you have saved. You would be able to write it in the exam. Same goes with the LSTM. It is able to predict what is the final output. So that's how your LSTM works. It is just a special kind of RNN. Your all the gates that are there, they use sigmoid function and tanh as the activation function. Sigmoid and tanh is used as your activation functions in all the gate, whether it is forget, input, or output gate. Any question, guys? So forget gate discards old info, input gate adds new info, cell state stores important memory, and output gate shares the relevant info. Are we good, guys? Okay. So this is RNN and LSTM. What I have done is, as usual, I have created a small notebook, and I have already done this because these all execution takes time. I've written everything in one cell. You can good amount of comments are also available what each and every step is doing. So if we closely look into this one, we still have 20 minutes in hand, so let's go through this. We are importing important libraries. NumPy you guys are aware of. Are you aware of TensorFlow, Keras? At least you have heard names. Okay, yeah. So what is TensorFlow used for? Correct, correct. Right. So it is for deep learning only. Same way, over here also, we are from TensorFlow, we are taking TF, we are taking Keras, layers, IMDb for just the data set, that is the movie review data set, and pre-processing, that padding and all that we require. That's why I'm taking this pad sequence also. So TensorFlow is a open source machine learning framework. It is developed by Google only. Okay, so it is used for building and training machine learning and deep, especially the deep learning models. The core feature is the computational graph which you get of this, which allows you to define the mathematical operation as nodes in the graph and then execute them effectively. All this thing, Keras is there. Kira's model training, it is also one of the important things that we use in this RNN or the neural network. So this is what is which is the most important library is TensorFlow. Then random seed we are setting to 52 for NumPy and TF 54, sorry, 42. That is generally considered the best one. Loading the dataset, that is the IMDb datasets, which has 50,000 movie reviews labeled as positive and negative. So Keras provided its pre-tokenized, with each word represented as an integer, will only use the top 10,000 most common words that you have. So vocabulary size that we have kept is 10,000. We are taking train and test IMDb loading, and take the words that are in the top 10,000, that is in the vocabulary. So this is my input output. We have the labels as positive and negative, one for positive, zero for negative. Now pre-process the data. So all reviews must have the same length. So we pad them with zero or trim it if it is too long. Why this is required? Any idea? Why padding is, this is known as padding. Why is padding required? But why? Why can't we have multiple sentence? You are on the right track. It is for the same length, but why? Will my system not be able to process it? Yes. So your RNNs and LSTMs are often trained in batches for efficiency, okay? And batches require uniform input shapes. And padding will ensure all the sequence in a batch have the same length. So that's where, as you mentioned, just that your words would be at different positions and all those things, just to make sure that everything is of the same length, same place. That's the reason we apply padding. So padding solves the problem of your multiple length size by adding dummy values like zero. If I'm saying the padding size is 200, and one sentence is of just 10 as the length, so what you can do at the end, it will add 000, so it will, everything will become of the same size. If I say first sentence is I love AI, second sentence is deep learning is amazing, so first sentence has three words, whereas second sentence has four words over there, and I want the same sequence of same size. Let's say the sequence of size of the sequence should be four. So in I love AI, the last word would become as zero. That is what is padding. Padding is like a pre-processing that you are doing to make sure that all your values or all your sequence are of same length. None is shorter, none is too long. Whichever is too much long, we don't want to process that, we will trim it out. If it is shorter, it will add zero over there. The most common padding value is zero only. Is this clear, guys? Yeah. You, no, it's not about making sense. If I'm saying I love AI and deep learning is amazing, it's not that the sentence have the same meaning, right? It's just that so if you have a machine learning model, let's forget about deep learning or neural network for a while. If I'm working on a logistic regression only for say, and my input are 20 columns, okay, if I'm giving in one line I'm giving 20 columns, all the values. In third, I'm just giving 10 inputs. Will my system work? Will my model work, or it will throw an error? Because of same thing happens over here. Yes, and in the end. So padding is adding it at the end only. Okay. Okay. So real data like your sentences, time series often have different lengths. Padding will make them of equal size because this is a prerequisite, or this is the functionality which is there in your RNN or LSTM. So padding is adding extra empty spaces, and instead of empty spaces, you are adding that zero to your sequence, so that sequence in a batch have the same length. Think of it like you are giving as a box, okay, box sizes of 200. You have to make sure that all that 200 box sizes are filled for each row, otherwise it won't work out. So your padding adds empty spaces to shorter boxes, so everything fits nicely over there. Okay, so that's what we are doing, padding over there. And define a function. This is for building the model. We will tune this later, and that's what tuning takes time. I have already executed and kept it. Building a simple LSTM model for sentiment classification, because this is IMDb rating. We are looking at positive and negative. Any who have attended my sessions prior, or who have this knowledge, what is this called? This red text. What is this red text? Anybody can tell me from this to this? What is this? Have you heard about doc string? Uh, Comments are more that yeah, in simple and layman terms, you will call it comments only. Green ones are more like comments. These are known as doc string. And in real time, when you work in industry, every code you will see is having a doc string. Any guesses why should we have a doc string? It is a very good practice. Why should we have a doc string? For readab Yes, so it is for the readability and self-explainability, self-explanation that you have. So doc strings make your code self-explanatory. Like if I give you just notebook, you can read, build a simple LSTM model for sentiment classification. What are the arguments? Embedding dimension. What does this mean? Size of word embedding vector. LSTM units. What does it mean? Number of LSTM units. Dropout rate. Dropout to prevent overfitting. Returns what it is. What is the output of this? It is compiled Keras model. So that is what it is. Readable, it is professional. It is very important in machine learning projects where functions can get complex. This is a small function. If you miss it also, that's fine. But in real time, when you're working in industry, you have to write these doc strings, otherwise your code won't be considered as a legitimate and a good code for the production deployment. Okay. It's great. So this is sequential layers.embedding. I'm giving my vocabulary size that was of 10,000. Embedding dimension. As of now, I've defaulted to 32. LSTM inputs, number of LSTM units that you will have, that is 32. Dropout rate, so that you don't have that overfitting. We will go through this uh, hyperparameters in details. Don't worry about that. And activation function I'm keeping at sigmoid. Optimizer Adam, again these all things goes back to basic neural network, where I have covered what is Adam, what is sigmoid, and all this thing. Loss function I'm using binary cross entropy. We have discussed this thing. And matrix I'm looking at accuracy. So this is the function that is there, which in which I am creating a keras model, and it will get compiled also. So just run the model, fit it on X train and Y train. Epochs are your one forward feed and then a back propagation, means learning from its own mistake. I'm keeping it three only, a smaller number, so that training is faster. Batch size 64, this is the batch size that I was telling you, that it should be all the sequence in that batch should be of same size. Validation is split, the train and test is split that we want, and verbose is equals to 1, that it will print your outcome also. Evaluate your model on X test, Y test, and then I'm just doing the hyperparameter tuning on these three parameters. I'll go through this, and then again creating the model with this iterative ones, and figuring out which is the best output. So if you see, multiple iterations have occurred, and these are the test accuracies, different accuracies, all are nearby only, but the best is this one, where embedding dimension is 64, LSTM units is 64, dropout rate is zero point 0.2. This is your accuracy curve, and this is the loss curve. What is loss curve? Loss curve is your error curve, that how much error is there, whereas accuracy is how well your model is there. This is on the validation, that is test, and blue one is on the training. So training accuracy is around 87%, and your test accuracy is around 81. So it is not an overfit model, a good to go model that we are having over here. With multiple iterations, we were able to get this. Now, what are these hyperparameters? Let's go through one by one. So, what are different hyperparameters in ANN that we have, or in any neural network? Anybody remembers? Anybody knows what are the different hyperparameters in ANN? Anybody remembers name as learning rate, epochs? At least these will remain same. But anyhow, let me go through this. A few important, there are many hyperparameters, but few important ones that we generally play around with is, one is number of LSTM units. What is this? Number of neurons in your LSTM layer, not your RNN layer, in your LSTM layer. How many neurons would be there? So if I am saying LSTM unit is 32, it means I am having 32 neurons over there. More units, model can remember more complex pattern, but it doesn't mean that you will just overburden it, because then your computation also becomes too expensive. If you have very small amount of LSTM units, underfitting might happen. If you have too many, then overfitting and slower training would be there. So generally we keep the value between 32 or 64, like that. These are the most common values that I have seen in LSTM. Then comes embedding dimension. Okay, this EMB, embedding dimension. What is this? This is the size of the word embedding vector for each words in the NLP task that you have. So bigger dimension, richer representation of the word, too small. So what happens, each and every word that you have, like I'm saying, how are you today? So how will be broken, this each and every word would be broken down into embeddings. What are embeddings? Embeddings are the numerical representation of each and every word. Larger, so it comes in a vector format. So, um, so to understand this, if I say vector size 32, I will have 32 numbers, 32 different decimal numbers. The vector size is 32, in which my complete sentence, how are you today, would be stored in the numerical format. Larger the dimension size, richer is the representation of each and every word. It is able to capture the crux of that word. But again, too too big, slower training will happen. If you are taking very small embedding side, you might lose the meaning of the word and the context also. Then we have dropout rate. What is dropout rate? Fractions of neurons randomly turn off during training. Okay. What happens with that? It prevents the models from memorizing the complete training data. So if some neurons are turned off, they won't be remembering your training data. Later on, some neurons would use. So common value ranges between zero point 0.2 to zero point 0.5, out of which zero point 0.2 is something commonly I have seen. Then comes your learning rate. Learning rate is how big a step your optimizer will take. Like in ANN, what happens in epoch? You have input, you have hidden layer, then you have the output. So it will flow through this. It will check, okay, my output is matching or not matching. So it will go back over there again. It is not that the output will go. It will say, okay, you have to adjust the weights. Adjustments of the weights happens over here. Who does this? Optimizer does this thing, that it is adjusting the weight, and again it is changing, it is sending it so that your loss becomes lower and lower. But it can lead to overfitting also. So your learning rate has should not be too small or too big. It should be optimal. Okay, then comes your batch size. What is this? Number of sequence processed together in one training step. Okay, small batches, it would be slower, but it would be more accurate because the weights could be updated accordingly. Means if you're processing a small information together, it is easier to process. Whereas large batches, it would be faster, but it would be less precise in output. You are moving things together. Number of epochs, how many times your model will see the entire data. Means how many so this is known as, when input out to output it goes, it is known as forward feed. And when it goes from back again adjusting the weight, it is known as backward propagation. This together, this forward feed plus backward propagation, will make one epoch. Okay, so that's what happens, that your epochs are how many times it will iterate through, so that you are not overfitting or underfitting your model and getting the accurate results. Generally, these are the six hyperparameters we most of the times work along with in making my LSTM models better. I'm not going into RNN because RNN is not used anymore now. Everybody works on LSTM only, which is nothing but the advanced version of RNN. That's RNN, and that's the reason that I have covered in this notebook also RNN only. Any question, guys? Yes, no? Okay, so if no question, this is the very basics of RNN and LSTM. You can go through this notebook. It is present in the folder which I have already shared on WhatsApp. I will be again sharing this along with the recording, and the next session that we will have. So till this point, we have covered the very basics of the neural networks that are the base for your Gen AI. From the next session onwards, we will get into transformers, encoder, decoder, and all that, which is the start, the actual start that everybody talks about when they are teaching you Gen AI. Then that's what they talk about: encoder, decoder, and your diffusion models, your encoder only model, and all those things. That is your Gen AI actual start. This was more of a brush up, just people who are not aware of neural network, to bring them to speed, that what is ANN, what is CNN, what is RNN, because without understanding this, you can't understand transformers. Okay, so we'll meet next Sunday then, and that's it for now. Thank you, guys.